So Chika, what took you so long to join?
The DC was connecting.
No, okay, so let's quickly start immediately. We are going to be doing chemistry, the remaining 2019 chemistry from tomorrow. So try as much as we can to do some physics. Then tomorrow we'll continue with the rest of the chemistry.
Okay, sir.
Tell your uncle that I called him yesterday, but he didn't pick.
For
Tell your uncle that I called him yesterday.
hello. Okay.
So do we continue? Chika, can you hear me? Can you hear me, Chika?
So we can continue.
Okay, a simple barometer is constructed using a liquid Q.
Hello.
Can you hear me? Tika, can we continue?
Yes, sir, we can continue.
Okay, a simple barometer is constructed using a liquid Q1 of density 16.2 gram per cm cube. Calculate the least length of the tube to be used to measure pressure of 1.5 atmospheres. Given density of mercury is equal to 13.6 gram per cm cube, and that 1 atmosphere is equal to 76 cm cube of mercury. So the options are A, 1,358 millimeter, B, 957 millimeter, C, 760 millimeter, and D, 638 millimeter.
Hello.
Yes, can you hear me?
Yes, I can hear you.
Can you see my screen?
Yes, I'm seeing it.
You can see it very well, but
Yes, sir.
okay. So the answer is 957. Why? Because density is inversely proportional to the size increase. So if you take the density times the distance that can be measured, is the same as the density of mercury times the distance that can be measured by the mercury. So get that distance as 63.8. So if 63.8 is for 1 atmosphere, X will be for 1.5 atmosphere. So make S the subject, then you get 957 millimeter. If you check the past question, you see that they got it wrongly. So take note. Most of the things, some of the things, few of the things they have in past questions, they don't do it very well. To research before we come up with this.
Yes.
It's clever. Can I move on?
Yes, I'm writing this.
Okay, I'll leave you time
Hold
to
on.
quickly, be fast. Yeah, hold on.
Yeah, you can move on.
Okay. When you can see the question number 28 on your screen, let me know.
Okay, sir. That's 28 I'm seeing now.
Okay, showing already, okay? Can you see the sketch up there? A bar AB is balanced horizontally on 2 knife edges, as illustrated in the diagram above. Determine the weight of the bar.
It was 28 that I was showing before, not 27. I even thought it was 27.
Said what?
I said it was 28 that that was showing on the screen before.
Can you see 28 with a diagram on top now?
Yes, sir. I said before it
Okay.
was 28 that I was showing.
Okay. I didn't know. So let's continue. A bar AB is balanced horizontally on two knife edges as illustrated in the diagram above. Determine the weight of the bar. Option A, 10.0 newtons, B, 20.0 newtons, C, 40.0 newtons, D, 50.0 newtons. So in order to understand this first, we had to redraw what is up there. The only thing here now, the second sketch, is that we now indicated where the weight is acting at the middle, and it's represented with F3. So F3 is equal to weight. So the weight is at F3, which is equal to W. At the middle of the forces, F1 and F2. And it is the weight that balances F1 and F2. So we have what we call the first and second conditions of equilibrium. What is that? Okay, the first condition.
You say number 27 to me after this class.
Okay, you didn't finish writing it.
Yes, I didn't see number 27 on the screen. It was 28 I was copying.
Okay, you are copying 28 instead of 27.
Yes. It was not showing on the screen.
See, it's your duty to know what you're seeing on the screen and report to me so that I'll show the right thing, Abby.
Yes.
How can you be seeing another thing and I'm explaining another thing and you did not call my attention since and I finished and went to another one and you're calling my attention to what I passed? Chika.
Sir?
Let's start afresh again. Make sure you're telling me what you're saying so that I don't have to come back again. Can you see 27 on your screen now?
Okay.
Can you see 27 on your screen now?
Yes, I can see it now.
A simple barometer is constructed using a liquid Q1 of density 16.2 gram per cm cube. Calculate the least length of the tube to be used to measure pressure at 1.5 atmospheres. Density of mercury is equal to 13.6 gram per cm cube. 1 atmosphere is equal to 76.0 cm cube of mercury. So the options are A, 1,358 millimeters, B, 957 millimeters, C, 760 millimeters, D, 638 millimeters. So density is inversely proportional to the size increase. And because of that, we set out this equation like this. So for that Q that you don't know, 16.2 cm can be 16 point, that's Q1 you don't know that has the density of 16.2.
Hello.
It can measure X, 16.6, measure what corresponds to 1.5 atmospheres. So make S the subject of the formula, and you get 957 millimeter mercury. That is the answer. And like I was noting the other time, I told you that when you check past question, the answer should be either D or something. Or take note, that should be what the answer should be. So let me know when you're done copying it so that I'll move to the next screen.
Okay.
Are you done?
So you can move to the next one.
Okay.
Doesn't work when it's checking. Doesn't work when it's checking.
Please, once you can see 28, let me know.
I can see it. Sir.
Can you see 28?
Yes, I can see it.
Okay. A bar AB is balanced horizontally on two knife edges as illustrated in the diagram above. Determine the weight of the bar. A, 10.0 Newton, B, 20.0 Newton, C, 40.0 Newton, D, 50.0 Newton. So solution, I simply redrew the diagram that we have here, but because we are told to calculate the weight, so I indicated the weight. The weight is supposed to, because these two forces are equal, the weight should be at the center and it should be towards the ground. So the weight is F3 and it's at the middle. But before we can solve this, we need to know the two conditions necessary for equilibrium to occur. Or actually one of the conditions to be able to give us the right answer. So for equilibrium to occur, the total upward force must be equal to the total downward force. So these are the upward force, the F1 and F2. So the total of it must be equal to the down. That's why we have F1 plus F2 must be equal to F3. So 20 plus 20 equal to F3, which is simply equal to 40. That's the first condition of equilibrium. Second condition is that the total anti-clockwise moment must be equal to the total clockwise moment. If there was a case where we are told to calculate the distance between C and B, then we would have used this second condition for equilibrium to do the calculation. But I just stated it so that you know these are the two conditions necessary for equilibrium to occur. In case if you have similar problems.
So anytime you say we should find weight, it's always in the middle.
It's only the what?
I said anytime they say we should find weight, it is always in the middle.
No, it's
what
not
we're
always.
looking for is in the middle.
This one is only in the middle because the two forces are already balancing. Is that clear? In other cases, they will give you the distances. So you have to use this second condition of equilibrium to either calculate the position where the weight will be.
Okay, so.
Okay, but take note of the two conditions necessary for equilibrium to happen. Can you state those two conditions now?
Yes.
Okay, so let's move forward. If you can see my screen, let me know. 29.
I can see it.
You can, okay. To obtain a virtual, erect, and magnified image from a thin converging lens, an object must be placed A, between the focus and the lens. In this case, the lens can also be called the pole. B, at the focus, C, at the focus. C, between the focus and twice the focal length. D, between twice the focal length. Between twice the focal length. I wouldn't know whether anything is still remaining, okay? So the answer is A, between the focus and the lens, because for converging lens, depending on where you place the object, that determines whether the image is going to be real, virtual, inverted, diminished, or magnified. So we're going to draw the possible cases. So this is the first case. And in this case, the object is placed after C. So what kind of image image does an object that is placed is between F and C. So you can see of curvature. F is the principal focus. Image is real. It's inverted. You can see it's inverted. It's diminished. It's not magnified. It's reducing. So these are the properties of object that is placed after center of curvature. So you can see the image. It's inverted, diminished, real, and between F and C. So another instance is where you place the object at C, at the center of curvature. You can see the object here. You can see the image. Here, the image is also at C. The image is real. It is also inverted, and it's at the same size of the object. You can see the size of the image is just the same as the object. So that's another case. Now, another case is when you place the object, this is the object, between center of curvature and focus, between C and F. So in that case, it will produce this image. And this image is beyond C. It is real, it is inverted, and you can see it is magnified. It's far bigger than the object. So this is another case where you place the object at principal focus, F. So in this case, the image is at infinity. You can see, you cannot even locate the image here. The image is real, the image is inverted, and the image is magnified. Then lastly, you can have the object placed between the pole or the lens focus. In that case, this is the image. The image is behind the mirror. It is virtual, erect, and magnified. So from the illustration I've given you now, which of them do you think answers the question? Check out.
The last one.
The last one, good. Because they are looking for the one that will produce an image that is virtual, erect, and magnified. And you can see the last one produces an image that is virtual, erect, and magnified. But where is the position of the object? It is between the pole and focus. And that makes A the answer, between the focus and the lens. So another thing to take note of here is that for a concave...
If you want to.
You said what?
So I said, if you want to know all this, how will you know all these diagrams?
Yeah, you can only know them by practicing them.
Like, how did you know the converging lens was meant to be? Okay.
You can only know them by practicing them. Is that clear?
Okay, sir.
Yeah, that's why I took our time to draw all of them, so that at your own time you can practice them. Is that clear?
Yes, sir.
So these are the different type of images that a concave mirror can produce. For a convex mirror, the image is always smaller, erect, and virtual. For a convex mirror, so the image is the same thing no matter the position of the object. But for a concave mirror, you need to have, it has different positions at different positions of the object. So another thing you need to know that a concave mirror can be used as a shelving mirror.
Okay.
So that's the application. Okay. So let's move forward. We just finished 29, but
Yes, sir.
so let's look at 30. Please, once you can see 30, you let me know.
I can see it now.
Okay. The diagram above represents a transverse traveling wave Which 2 points are 180 out of phase? Okay, you have option A and E, option B, B and D, option C, C and F, option D, D and F. So option A is A and E. A is here, E is here. So they actually are on the same phase. B and D, this is B, this is D. So B is 90 out of D and another 90. So 90 plus 90, you have 180 out of D. That makes it the answer. The option C, C and F, this is C, this is F. So C is just 90 out from F. Option D, D and H. This is D, this is H. They are on the same phase.
I don't really understand.
Okay, so watch again as I'm demonstrating. Can you see D? Can you see D? Can you see D?
Yes, I can see.
Can you see H?
Yes, I can see.
Can you note the places where they are, both of them are formed? They are, both of them are on the trough.
Yes, I can see.
So they are on the same phase. Can you see A and E?
Yes, I can see.
Good. They are also on similar points on this, just like these ones are on similar points.
So why is A and
also,
E not the answer?
Huh?
Sir, why is A and E not the answer?
So that's what I'm explaining to you now. You can see D and E, they are on similar position, just like A and E. If you check the past question, they gave A and E as the answer, but they are wrong. Can you see the positions of D and E? Can you relate them to A and E?
Yes, I can see it.
Okay. So if D and E, if A and E is the answer, D and H should also be the answer. Because you can see that they are on similar places on the sketch.
Yes.
Okay. So the other ones that are not the same now, you have B and D. This is where B is, and this is where D is. So we have okay, we have C and F too. This is C, this is F. So this cannot be because they are at are you looking at this sketch? Can you look at this sketch? From here now to here
Yes,
is 90. From here to here is 90. From here to here is another 90. So a complete half of the circle is 180. Another complete half is 180, making it 360, which is the complete. So if you have from here to here alone is 90, from here to here is 90. So if you look at B and D, from here to here, 90 and another 90. So making it 180 out. And you can definitely see that both of them are not on the same point on the wavefront.
Okay, sir.
Did you get that now?
Yes, sir. Hello?
Did you get what I just said?
Yes, I got it.
Okay, so let's move forward. When you're seeing question number 31, let me know.
Okay. I can see it now.
Okay, two objects P and Q of masses 100 kg and 20 kg respectively are 1.2 meter apart on a horizontal surface. Calculate the net gravitational force acting on Q. G is equal to 6.67 times 10 to the power minus 11 Newton meter squared per kg squared. Option A, 1.11 times 10 to the power minus 7 newtons towards P. Option B, 1.11 times 10 to the power minus 7 newtons towards Q. Option C, 9.26 times 10 to the power minus 8 newtons towards P. And option D, 9.26 times 10 to the power 8 newtons towards Q. Now, solution. Newton's law of universal gravitation states that every particle in the universe attracts every other particle with a force that is proportional to their masses and inversely proportional to the square root of the distance between them. And that force must act along the line joining the centers of the particles. So this is the statement of the Newton's law. F is proportional to the product of their masses all over the distance between them squared. Then changing the constant of changing this proportionality sign with a constant G, you now have this. So if you substitute these values, you have for G, it is given 6.67 times 10 to the power minus 11. The two masses are 120 all over 1.2 squared. So if you do this calculation, you get 9.26 times 10 to the power minus 8. And it must be towards P, not towards Q, because Q must be attracted towards P in order for it to obey the Newton's law that states that two of them must be attracting each other. Do you understand that?
Now, when I don't understand, the Q must be attracted towards P. Must be attracted towards P, sir.
Must be attracted towards
P. I don't understand that statement.
Okay. You're looking at Q. Can you see this Q that you're looking at? Can you see Q here?
Yes.
So they told you to calculate the net force acting on Q.
Okay.
So Newton's law of gravity states that they must attract each other. Every other body must be attracting the other one. So the force acting on Q must be in such a way that it will be towards P, because you're talking about P and Q. If you're talking about the force on P, it should be towards Q. But if you're talking about the force on Q, it should be towards P, because two of them have to be attracting each other. So if you have a force acting on this Q, it has to be directed towards the other one. If you have one acting on this one, it will be directed towards this other one.
Okay, sir.
Is that clear to you?
Yes, sir.
Okay, so let's move on. Please, if you can see question 32, let me know.
I can see it, sir.
Okay, the primary of a transformer has 100 turns and its secondary has 200 turns. If the voltage at the primary is 100 V, determine the voltage at the secondary. Option A, 50 volts, B, 100 volts, C, 200 volts, D, 400 volts. Solution. Mutual inductance is the flow of induced current or voltage in a coil due to the alternating or varying currents in the coil, neighboring coil. So if you're having a step-up transformer, you're going to have lesser coil on the primary and have more on the secondary. Whereas if you're having a step-down transformer, you're going to be having more coils on the primary, and you'll be having less on the secondary. Because the more the coil, the more the EMF. And that's what we have here. The more the coil, the more the EMF. The more the coil, here the coil is represented by N, which is the number of turns. And this is the EMF. And it's inversely proportional to the current. So that's why you have to transpose the current here. You have to have the primary on top and the secondary down. But for the
two types of coil, their names step up and step down.
EMF, which is also the... Come again, I cannot hear you.
Like, what is step up and step down?
Okay, I just explained it now. Once you look at the transformer, this side is known as the primary coil, and this side is known as secondary coil. This side primary, this side is secondary. Once the number of coils in the primary is less than that in the secondary, call it step up. Because you can see EMF is being stepped up from here to here. Here, there is lesser number of coils. Here, there is more. But you can see it's moving from more to less here. You call it step down. If it's moving from less to more, call it step up. So this is a step up transformer. This is a step down transformer. This side is the primary coil. This side is the secondary. The same thing as this other one.
So you can move on, I understand now.
You understand now, good. So using that, you can state this formula, ES over EP equal to NS over NP. So ES is what you're looking for. EP is 100 equal to number of turns for secondary is 200. Number of turns for primary is 100. Make S the subject, you have 200 V. And that's why 200 is the answer.
Okay, sir. I'm jotting that
Can move on, ba?
down. Yeah. So
Once you
move
can
on.
see 33, let me know.
I can see.
Okay. In the diagram illustrated, a block of mass M is at rest on a plane inclined at an angle theta to the horizontal. As theta increases, the velocity ratio of the plane does what? A increases, B decreases, C remains the same, D decreases, and letter increases. Please, this is a mistake, and letter increases. Okay, solution. For the mechanical advantage and velocity ratio for an inclined plane, if the frictional force is absent, then the mechanical advantage is equal to mechanical ratio, and both of them are equal to 1 over sine, the angle of inclination, 1 over sine. But if there is actually friction, then the MA is actually less than the VR.
Well, sir, they didn't mention the mechanical advantage here.
Huh?
They didn't mention the mechanical advantage here.
No, I didn't say they mentioned it. I'm just giving you a concept behind the solving.
Okay.
So in case if they mention it tomorrow, so that you know that it's also equal to 1 over sine theta if friction is absent. Is that clear?
Yes, sir.
Okay. So velocity ratio is equal to 1 over sine theta. Now, they are asking you, if you increase theta, what will happen to the velocity ratio? Is that the question?
Yes.
Okay.
Now, yes.
Good. So let's say the angle is increased from 40 to 90. Let's see what will happen. So using this formula, VR is equal to 1 over sine 45. And sine 45 is 0.707. So if you solve this out, it will give you this. Or if it is 90, sin 90 is 1, 1 over 1 is 1. So you can see that when you increase the theta from 45 to 90, the VR reduces from 1.44 to 1. That means it's actually increasing. As you're increasing the theta, the VR is decreasing. That makes option B the answer, decreases. Suleiman, please correct more for me. Come on, show the one.
I did I times it by 2.
You said?
Like, how did you know it will be sin 90? Or anytime you just
How do
want
I
to
know it's
do
what?
sin 45, it is always going to be sin 90.
No, I just assumed. You can actually assume any theta you want, but just make sure that the second one is bigger than the first one. Because they want you to check once you are increasing the angle. You understand? Anything you use, it will give you. But why would you choose 45 and 90? Because with 45 and 90, even without calculator, you can know what their signs are.
Yes.
It's generally known that sin 90 is 1 and sin 45 is 0.707. So you use these theta that you can easily, without calculator, you can solve out with. Come here, Aliyu. Sit down there when he comes.
Okay, so can continue.
Is that clear?
Yes.
Take vitamin. Can I move forward?
Yes, I can move forward.
What number did we just do?
33, why number 34 now?
Okay.
I can see it.
You can see it clearly.
Yes.
When the speed of a car is halved, its kinetic energy is A, doubled, B, quartered, C, halved, D, quadrupled. So in order for you to get this, you need to know the representation for both kinetic energy and the relationship between kinetic energy and speed. In order for you to know what happens to the kinetic energy when the speed is halved. So the relationship between kinetic energy and speed is that Ke is simply equal to half mv squared. This place V is showing us the speed. So we're going to assume values for V and we'll try to have it. So when we have it, so we have it and we see the relationship. So we have K equal to half mv squared. So let's say that V is equal to 1. And let's
Can you zoom in a little?
Sorry?
Can you zoom in?
Okay. Aliu, he's talking to somebody and you are listening and you're keeping quiet.
Yeah, I can see it.
Talking to. Are you seeing it well now?
Yes, I can see it now.
Why did you ask you whether you're working here? You say you're working here.
Sir, can you hear me? I said I can see it now.
But did you ask you whether you're working here? You say you're working here. Why?
Hello.
Make sure you're taking care of what is happening there.
Sir, can you hear me?
Yes, I can hear you. Can you see my screen?
Yes, I can see it.
Okay. Do you have any question?
No.
Can you see my screen?
I can see it.
Okay. When the speed of a car is halved, its kinetic energy is A, doubled, B, quartered, C, halved, D, quadrupled. So we have solution KE, which is the kinetic energy. The relationship between kinetic energy and speed is that kinetic energy is equal to half mv squared. So let's assume, because what we are changing is the speed, let's assume that the mass is always 1. So we take for speed of 1, then we take for speed of 2, and possibly take for speed of 4. Since 1 is half of 2 and 2 is half of 4. Yes, I'm listening to you.
I said they said the speed is half. Why didn't we put V as half?
That's what I'm trying to explain to you.
Okay.
Are you listening?
Yes, I'm listening.
Good. That's why we tested for V of 4, 2, and 1.
Let's stop that now.
So if you say that V is half, you can also assume that it has moved. Is 2 the half of 4, Chika?
Sir?
Is 2 the half of 4?
Yes.
Is 1 the half of 2?
Yes. No, it is.
Good. Huh?
I said yes, it is.
Okay. So if you have the speed of the car from 4 to 2, from this our solving, you see that the KE is going from 8 to 2. If you also have the speed of light from speed of the car from 2 to 1, you will see that the KE is moving from 2 to 1. So if you assume the speed to be 1, what is the KE? Simply substitute. You're assuming mass to always be equal to 1. So if you substitute, you get half. If you assume the speed to be 2, the mass is 1, substitute, you get KE to be 2. If you assume the speed to be 4, substitute, you get your KE to be 8. So you see, as we are moving from, as we are having, you go from 4 to 2. The KE went from 8 to what? 2. So what's the relationship between 8 and 2? Or between 2 and 1? I mean, between 2 and half. What's the relationship? It's simply telling us that as we are moving the speed from 4 to 2, we are having it. The K is moving from 8 to 2. You can see this speed of 4. The speed is 4 here. The speed is 2 here. But here the KE is 8. Here the KE is what? 2. And you know that 1/4 of 8 is 2. So it has actually been quartered, whereas this one has been halved. So as you're halving the speed, the KE is being quartered. So if you forget about moving from 4 to 2 and you consider moving from 2 to 1, the same thing happens there. From 2 to 1, you can see that the KE is moving from 2 to half. So what's the relationship between 2 and half? 1/4 of 2 also gives you half. So the answer is quartered.
Okay, sir.
Is it clear?
Yes, sir.
Did you see the way we approached it? You have to take note of the approach. That's what matters. We assume the mass to be 1. This is the formula that you're going to use. But you assume M to be 1 in all the cases. Then you just vary the P by trying to have it. Using any value. It mustn't be 2 and 4 and all this. It can also actually be any halving value. You can use 3 and 6. Because you know that 3 is the half of 6. If you still do it, you will see that it's being quartered also.
Okay, sir.
Do we continue?
Okay, sir.
Okay.
Yes, sir.
Please, once you can see 35, let me know.
I can see it, sir.
Okay. A wire of length 400 cm is stretched between 2 fixed points. When plugged, its fundamental frequency is 150 Hz. Calculate the speed of the wave produced. Option A, 250 meters per second. B, 625 meters per second. C, 1,200 meters per second. D, 1,500 meters per second. Okay, solution, you can see the sketch here. So these are the 2 points, and this length is 400. Now, this length is actually equal to half the wavelength. So this length is equal to half the wavelength. But we know the formula for frequency is that frequency is equal to speed over wavelength. But we are not given wavelength. But we know that this length is equal to half the wavelength. So make wavelength the subject, you have 2L. So put it back into this equation. F is equal to V over 2L. So make V the subject, V is equal to F2L. 150 times 2 times 4, making it 120 meters per second. If you're done writing, let me move on if you understand it.
Sorry, how they say okay between 2 fixed points?
You say?
I was asking how did we know that it will be V over 2L? Because there's also another one for V over L.
V over what?
That did you hear me?
Also another one for what?
Another formula that is F is equal to V over
No, there's no F equal to V over L. It's only F equal to V over this sign, wavelength. This is the formula, F equal to V over wavelength.
No, like the other formula that V is equals to 3 over L over 5L.
Yeah,
And all those
depending on if this, you see this one is just starting from year to year. In some cases, it will go like this and come up like this and go like this and come up like this. So depending on the number of partitions that you have.
So sure, they didn't give us the diagram in the question. No.
Yeah. This diagram is just explaining what you read. You see, a wire of length 400. Can you see that? A wire of length 400. This is the length of the wire. From here to here is 400. Is stretched between two fixed points. So it's just between these two fixed points. They didn't tell you that it breathes somewhere in the middle. Now, when it is plugged, this is the wire. When you plug it, it will start vibrating up and down. Do you understand? So the diagram you draw is based on the question that you are given. The diagram I just gave you now is from what I read from the question.
Okay, sir.
Yeah. Okay.
We can move on.
Okay. Once you can see my screen, let me know.
I can see it, sir.
Okay, 36. The diagram above illustrates a waveform. Determine the number of wavelengths in it. Option A, 4, B, 3.5, 2, 2.5, D, 2. Solution, one complete circle is one wavelength. So if you consider this from here and here, this is 1, 2. So you can see that here from here and here completes one circle. Then this B from here and here completes another circle. Then this one is not even up to half a circle. So, but you have here, then if you combine it with what is here, this 1/4 plus this 1/4 will give you half. So you actually have how many? 1 plus 2 plus half. So it will give you 2.5. So one complete circle equal to one length, one wavelength.
So I said, sorry, please, what is the difference between the quarter and the half? This quarter looks like the half.
What's the difference between what?
On the wavelength, this quarter looks like the half.
Okay, actually, this is quarter. This one is quarter. Half is one full like this. Can you see this point? This is half. And this is another half.
Okay, yes.
It must curve fully like this to be half. Then if you curve again, it becomes one full wavelength, which is a complete circle. This one also, half of B, half another one. That's another one complete circle. But you have this here is quarter because it did not reach half. So you have this quarter plus this quarter, making it half. So we have 1, 2.5. Abi?
Okay, so I understand now.
Okay. So let's move on. Can you see 37?
Yes, I can see it.
Okay. A resistor with a fixed resistance value is called A, resistance box, B, standard resistor, C, shunt, D, multiplier. So what do you call a resistor with fixed resistance value? Solution, a standard resistor or standard resistors are resistors which have fixed values. Example, they can have values like 1 ohm, 2 ohm, 5 ohms. And this is how you represent a standard resistor. Whereas a variable resistor can have varied resistance. This is how you represent a varied resistor. So with that, you can see that the answer is B, standard resistor. So these other definitions are just what you need to know in this very topic. Okay, so we are signing off now. We'll be logging out. If I'm able to log in again, then we'll finish up. But if I'm not, tomorrow we'll be looking at chemistry.
Okay. So let me finish right.
Huh?
So I'm jotting this down.
You said?
So that diagram that you put for variable resistor, is that not the one for rail start? It looks like
What?
it's for rail start. The diagram for variable resistor, is it for rail start?
Yeah. Okay, you can actually use rail start to supply varying potential difference. But what I gave you is actually for
So
variable
they have
resistor.
the same diagram. So they have the same diagram.
I'm not sure about the one for the rail start, unless if that's what you've seen as the diagram for rail start. Are you clear on that?
Yes, sir.
Okay. So see you when I see you. Tell your uncle to call me. I called him yesterday and he didn't pick. Very important.
Okay, so I'll tell him.